Greetings and welcome once again to my new calculus channel. My name is John Gabriel, and in this final video I'm going to be talking about the development or the realization of numbers, and it's imperative that you watch the previous two videos carefully before you watch this video, because if you don't, you won't understand what I'll be telling you in this video. So this final video will give you the last thing you need to know about numbers. And there really is nothing more that you need to know about numbers. So let's begin. Now, in the previous videos, in part 1 and part 2, I gave you a build-up of how we realize number. And to summarize those ideas, I have a very nice number poster. So we begin with magnitude, which is just the concept of size, dimension, or extent. And that can be anything. It can be distance, mass, area, volume, anything. But we choose distance because it's the easiest to deal with, okay? So then we stumble on the concept of ratio, because as I showed you in the example with the person who was reporting a wound to a doctor, he had to describe how long the wound was, and he couldn't do it without using a ratio. And of course, I mean, if you try to do it using something like the nonsense of set theory, he never would have gotten there anyway. So anyhow, a ratio is basically a qualitative comparison initially of two magnitudes. And by convention, we call the one that appears first the antecedent, or that which is being measured, and the one that appears after the consequent, that which acts as the measuring unit. So the measuring unit and or equal parts of the measuring unit. Now, the unit is just an arbitrary ratio of equal magnitudes. As you see here, it's just some ratio you choose whereby you say this is going to be my measuring unit. And the next most important concept was a concept of quotientness, something which even the Greeks who came after Euclid did not understand. But I have finally understood it, and I'm revealing this knowledge to you. I'm enlightening you. This is important knowledge to know. It's so important that without it, you cannot understand the concept of numbers. So to even begin to deal with ratios that are useful, they have to have quotientness, okay? In other words, it must be possible to measure both the parts of the ratio with a common magnitude. And if it's possible to measure them with one common magnitude, there are innumerably many others, because all we have to do is just break up the common magnitude into equal parts. And the next step becomes obvious. We can define numbers out of these ratios. So for example, we can say that 1 is the measure of this ratio here. Okay, the measure of this ratio. 2 is the measure of that ratio, and so on. Okay. And then finally, we can get to fractions, which are ratios of ratios, or rather ratios of natural numbers. In this final episode, I'll be dealing with a ratio that has no measure. And now you should be able to know which ratio doesn't have a measure. Any ratio that doesn't have quotientness doesn't have a measure in algebra. Yes, you can approximate a certain measure to that ratio, but it's never a complete measure. Okay, so it's not a measure because measures are by definition complete. Now, what does it mean to have a ratio without measure? Well, let's look at that. Now, if you have a circumference like that and a diameter, yeah, then this ratio here has no quotientness. And what that means is that you cannot take this part here and or equal parts of it. It doesn't matter how many parts you divide that section up into. there's no number that you can divide it up into, so that it measures both this consequent and both this antecedent, because it needs to measure both of them, okay? So it'll always measure itself, but does it measure this part? So you do that, and then you say, take your compass, and then flip your compass around again. And then finally you see, after you flipped your divider around a few times, that there's this little bit left over. There is no way to quantify this little bit using this unit and or equal parts of it. And that is what algebra does. Okay, that's how you get numbers. That's the whole point of what I've been telling you in the past 2 videos, and now finally concluding in this video. Algebra sacrifices precision for generality. It's a small price to pay, because in any event, we never deal with anything but those quantities that you think of as rational numbers. There is no such thing as an irrational number. Not even the gods can measure this ratio algebraically. Geometrically, yes. Algebraically, no. No one can. Not even the gods. Okay, higher beings than us. Now, a number is a name given to a measure that describes a ratio of magnitude. So from 0.1 to 6, all these are the foundation for a number. And you might say, well, that sounds complicated. But guess what? Try to learn from the drivel of mainstream mythmatics. Okay, first of all, you need to believe in these 9 beliefs here. Things like infinity, like extensionality. Okay, some of these are, you can actually say they're sensible, but the majority of them are not. And of course, number 6 is especially problematic. Okay, so didn't mean to do that. Number 6 says there exists an infinite set. That's total BS. There isn't anything like an infinite set. And also, this axiom of choice is also problematic. So these theorems, don't be fooled when you read things like Abian proved consistency and independence of 4 of the Zermelo. Oh, so he couldn't prove the rest of them? No, listen, there is no consistency here. This is not mathematics. This is nonsense. This is Jewish mythology, okay? Simply because George Cantor was a Jew, and I'm not railing against the Jews, but, you know, George Cantor wasn't a mathematician. He wasn't even a mathematician's arse. So he started the idea of sets. And look, from the very first sentence, it says Zermelo-Fraenkel axioms are the basis for Zermelo-Fraenkel set theory. And it says epsilon stands for exists, whatever that means. How can something exist? It doesn't even say how. For all, and E stands for is an element of, without even defining what an element is. Okay, and then the first thing says if X and Y have the same elements, then X is equal to Y. But element is not defined. And guess what? Element in set theory is the same as set. Okay, in other words, it's all circular bullshit from beginning all the way to the end. This is not mathematics. This is what people who have no aptitude for mathematics study. Know why? Because you can bullshit as much as you like with this. You can say that you can take one ball and create 2 identical balls out of it. And you can have thousands of paradoxes. And, you know, when you have things like that, it should raise red flags in your mind. Okay. And there are paradoxes, and there are strange things happening, because this knowledge is illogical, it's irrational, and it's not mathematics. So I've given you everything you need to know. Now, you can get my free ebook called The Importance of Learning the Right Way. What does division mean in mathematics, and how does it affect all other arithmetic concepts? You can either buy it here without a watermark, or you can get it free on academia.edu. And if you come over here, you need to create an account and log in to be able to read these articles. All of these articles are free, and there's some books as well included here. But you have to log in, and you cannot read any of them if you're not logged in. you'll get an error message of some sort. Now, this is one of the most important books I've ever written. Okay. And I'm not a naturally gifted writer. So I've done my very best to explain the concepts as well as I can. And I think I've done a good job. And if you don't believe me, well, then download the free ebook and study it. And you can support me by buying the book without the watermark. Okay. I also throw in my theory of knowledge, which is knowledge acquisition through inferential suspension. And I show you how, when you learn garbage like this, your ability to learn is harmed, toxically, by the way. You become so traumatized that even sensible information later on in your career doesn't make sense because your mind has been filled with so much bullshit that you cannot think reasonably and logically anymore. You start saying things like, I can define anything I like. And everything is based on axioms, which is total dribble, because if that were true, then you never would have had geometry or mathematics, and you wouldn't even be staring at this computer screen that you're staring at right now, okay, because it involves a lot of geometry. So don't be fooled. Pay attention to what I'm telling you. I do care about your future careers and your ability in mathematics. I don't care about the mainstream mathematics academics. They're evil, they're ignorant, they're incorrigibly stupid and incompetent. And it's not because of them that I produce these videos. And these videos will only help those minds that haven't been polluted with this crap that you see in front of your eyes right now. Set theory is nonsense. Absolute nonsense. It's not mathematics. It should never have been part of mathematics. And unfortunately, because of stupid people controlling the trash heap that is mainstream academia, this has been inserted into real analysis courses and is now, frankly, how they all obtain their piled higher and deeper shit PhDs. Okay? In other words, most of the dribble they do in PhD work involves this garbage. So that's pretty much it. I'm John Gabriel. And if you have any comments, please don't post garbage on my channel. I have issues with my eyes. I mean, it'll save me the trouble of having to just bin your comment because that's all I do. I don't read. I know when a comment is crap from the first line. So the minute I pick up an attitude or something like that, you've actually wasted your time, believe it or not, because I do not read everything. I simply can't. If you have a question, post only one question, and I might answer it. So if you're not a member of the New Calculus Discord, go to it. There are often many useful discussions on the New Calculus Discord, and we discuss everything from philosophy to artificial intelligence to cognitive science and anything else that really matters. But we don't discuss garbage like this, okay, because this isn't worth even reading, never mind thinking about. So that's pretty much it. I'm John Gabriel. This is New Calculus Channel. Till next time.